Dear participants of the International Workshop on Computer Modeling and Intelligent System 2022, we would like to present the topic of our research, the integration of decision-making stochastic models of air navigation system operators in emergency situation. The goals of our research are integration of decision-making stochastic and non-stochastic models of air navigation system operators in emergency. To build the individual decision-making models for the pilot, flight dispatcher, and air traffic controller in emergency, and to determine a collective solution for all operators participants of the process. Example of building CDM models for the pilot, flight dispatcher, and air traffic controller in conditions of uncertainty when it's required to choose an optimal alternate airdrome in bad weather conditions before the approach. Today we will overview the following questions: human factors problems in aviation, collaborative decision-making, operations of pilot, flight dispatcher, and air traffic controller, the integration of uncertainty model to collective model of CDM, CDM for pilot, air traffic controller, flight dispatcher in emergency situations, example of CDM in emergency, optimal landing airdrome in bad weather conditions, and results of our research. Despite the rapid and constant growth from the point of developed technologies applied in operational process of air traffic control, flight planning, modern airplane manufacturing, and improvement of hours flown by pilot and flight performance, the problem still exists. Statistical data shows that human error accounts for up to 80% of all causes of aviation accidents. Different professionals are involved in the provision of safety during the flight planning and operations process. Therefore, the specific characteristics of the documents which regulate the professional activity of each aviation personnel are different. It does not allow to develop the general algorithm of actions for all aviation staff in a specific situation. And then arises the conflict between actions and decision of involved staff who make the decisions at the same time for one situation. For solution of human factor problem, improvement of flight safety and reducing the risks, ICAO recommends using the following conceptual models. Let's look on the evolution of human factors models from 1970 to 2022. ICAO states that the proper collaboration is possible through the provision of air traffic management system members with an environment what ensures enough storage of significant information and its proper usage among ATM system. In this environment, all members closely interact with each other in making common decisions and achieve so-called collaborative decision-making. For the last decade, the usage of this concept foresees the improvement of overall performance of ATM system in general, taking into consideration the individual performance of ATM system members. This approach allows choosing the direction of action with respect to selected objectives based on decision made by each participant, and information exchange influence those decisions applying main decision-making principles. On the slide, you may see the overview of literature connected with the topic of our research. In the previous works concerning the scope of the current research, models are created for only two operators such as pilot and air traffic controller. In our research, we propose the collective model of CDM considering the factors influencing the choice and find collective solution for several participants in the process. We propose the model of the integration of stochastic and non-stochastic models for determining the optimal solution in emergencies. We are proposing the decision-making for the selection of the alternate airdrome in case of emergency in difficult meteorological conditions based on the method of decision-making under uncertainty using the criteria of Wald, Laplace, Savage, Hurwicz with the following output data. the decision-making payoff matrix, the set of alternative actions, the states of nature of factors, outcomes of decision matrix, conditions of decision-making under uncertainty. For better understanding the sequence of the decision taken in flight operations environment, there are described the main actions of aviation specialists according to the stage of aircraft operation. In the proposed algorithm of the CDM, we used the subjective-objective approach to optimal CDM, where it's required to define the route direction, to build a decision-making matrix with alternative solutions, factors influencing the decision-making, outcomes of choosing of alternative solution caused by factors influenced by decision-making. To find alternative solutions, to create the list of alternate airdromes, to define the factors influencing on decision-making for each operator, pilot, air traffic controller, flight dispatcher, and other aviation specialists. To define the outcomes, the possible consequences influencing on the selection of alternate airdrome in the case of an emergency. To create the matrices of solutions for each operator. Then to consider the condition of decision-making under uncertainty and choose the methods of decision-making under uncertainty. To find the optimal solution for each operator using the criteria of decision-making under uncertainty, Vogt, Webways, Savage, Hurwitz. To create the collective matrix of solutions, and to find optimal solutions for all operators using the criteria of decision-making under uncertainty. Here you can see an example of CDM in the situation where during the approach to the destination airport, the weather conditions are changing dramatically, lightning strike and thunderstorm activity closer to the destination airdrome. Here is initial data which is used to obtain the results of CDM. Considering the interaction of the flight dispatcher, pilot, and air traffic controller, it's necessary to understand their roles and responsibilities. Therefore, when making a decision, they analyze a general group of factors because the main purpose is the completion of the task, flight from point A to point B, including risk analysis, but from different points of view. And the final decision in flight makes the pilot. For rational CDM, each operator involved in decision-making has analyzed and considered the current situation. There are 3 operators in the CDM process: pilot, air traffic controller, flight dispatcher. The common factors which may have influence on decision-making for each operator were the fuel reserve on board of the aircraft, meteorological conditions, aircraft, airdrome and crew capabilities, location of obstacles in different sectors, air situation, and commercial point of view. Each operator composed a matrix of decisions where alternative solutions are alternate airdromes for the route Kyiv-Odessa, and each operator considers the same factor in the current situation but with different priorities. Expected outcomes considered by each of the operators are represented in 3 matrices made by each operator. With the help of Vogt, Webways, Savage, and Hurwitz criteria, by each operator was defined the optimal airdrome for landing in bad weather conditions on the route Kyiv-Odessa. To determine the consistency of operators, collective matrices were constructed, in which the factors influencing decisions of all operators are identical. In the CDM matrices used subjective factors, opinions of operators. Obtained results show that the optimal airdrome for landing according to the Vogt criterion is Kseniia, in condition that this flight is performed for the first time. Table 1. According to the criterion of Webways, the optimal airdrome for landing is Kyiv. Table 2. According to the criterion on Hurwitz, airdrome Dnipro, where optimism-pessimism coefficient is 0.5. Table 3. According to the criterion on Savage, airdrome Kseniia. Table 4. Here you can see the summary of the subjective-objective approach to the optimal CDM which we used for decision-making. As a result of our research, the integration of decision-making stochastic and non-stochastic models for operators in emergencies were made. The usage of CDM approach allows synchronize the decision taken by participants, the exchange of information between them, the effective balancing between safety and cost in collective solutions. The objective-subjective approach for determining optimal CDM in an emergency was obtained. An example of choosing an aerodrome in case of an emergency using the method of decision-making under uncertainty was presented. The calculations showed a balance between safety and cost using criteria WALT, maximum safety, and criteria SAVAGE, minimum cost and loss. The direction of further research is to develop the decision-making models for all CDM participants within a CDM concept, which may aggregate the solutions of partners in joint work within non-segregated airspace. The research was carried out for modeling of CDM between 3 aviation specialists: pilot, air traffic controller, and flight dispatcher, but it's planned to build the same models for other aviation specialists. Priorities and effectiveness of connecting specialists in the group of CDM will be in the next research. The research based on information from the following references. And the members of our research team are Tetiana Shmelova, Professor, Doctor of Science, National Aviation University, Department of Air Navigation Systems; Maxim Yatsko, Candidate of Engineering, Associate Professor, National Aviation University, the pilot; and Kseniia Lohachova, Postgraduate Student of National Aviation University, Flight Operations Officer. Here you can see the information about our Air Navigation System Department of National Aviation University, Ukraine. Thank you for your attention.